Alright, today we will start the lecture series and I will start with Section 1.2. You can download these notes from our Canvas site under Modules, look for Course Notes, and as I'm filling them in, I encourage you to follow along and also fill in your notes, and in that way if you kind of mimic the way I solve math problems, you will learn how to do them yourself. So let's start with the first problem. Is an equation, and now an equation has what we call a left-hand side, an equal sign, and then a right-hand side. And basically, one of the most powerful rules of algebra is very simple, and it's something like this. Whatever you do to one side of an equation you must do to the other side. Now the power in this is the word whatever. So you can pick anything you want. So if I want to add 4 to an equation, I can do it as long as I add it to both sides. Plus 4 on the left, plus 4 on the right. If I want to subtract 17, I can subtract 17 left, subtract 17 right. It'll work. You can also multiply. So I can multiply by a number, I can divide by a number. As long as I do it to both sides, it'll be perfectly legal maneuver. Okay, so that's our guiding principle, and our goal is to get the variable on one side, equal sign, and then a number. So for the beginning, our variable tends to be x, so we'll want x equals a number, just one number for now. Or we can have a number equaling x on the right. So as long as x is isolated on one of the two sides and we have just one number on the other side, we've accomplished our goal. So all we need is that principle and that goal, and we can solve most of these problems. So let's start with the first one. It says 7x minus 4 equals 9 plus 6x. Now I'm going to write this up here a little bigger so we can see it. 7x minus 4 equals 9 plus 6x. Now I tend to like to have my variable on the left side. So I'm gonna work on the left side. I'm gonna say I don't like that 4 there. I don't want that 4 next to that x. So to get rid of a minus 4, I'm going to add 4. And this is kind of an accounting method way of doing it, where you line up the numbers and you write the plus 4 on both sides, but you write it underneath the numbers. So now if I look at this and I say, okay, the 7x will drop down, minus 4 plus 4, they cancel each other, the equal sign drops down, 9 plus 4 is 13, and then the 6x drops down. So common mistakes I see students make is they don't line it up, or they forget the x's. So keep in mind, there's x's on the 7, there's x's on the 6. Okay, now we say, okay, I don't like that 6x on the right side. So we're trying to move our x's to one side, so let's subtract out 6x from this side. Now if I subtract 6x there, I have to subtract 6x on the left. And again, we add down. 7 take away 6 is 1 with an x on it. Equal sign drops down, 13 drops down. Plus 6 minus 6, those x's go away, so they're gone. So finally, and then the last step, we tend not to write what's called a leading 1, because 1 times anything doesn't change it. So 1x we just write as x equals 13. And that's going to be the answer. Okay, now there's an important step here, and that's called check. So they want us to check this. So let's try that. So for the check step, let's see where I have room. Let's try here. I'm going to take this 13 and I'm going to place it inside each of these x's. So instead of x now, it's going to be 13. And I'm going to plug it into the original equation. Just replace all x's with 13s. Now 7 times 13 is 91. 6 times 13 is 78. 91 take away 4 is 87. Equal sign. 9 plus 78 is 87. And if we get number equaling itself, then that checks out. So this 13 has to be correct. And that would be the solution to the first problem. Okay, 2 is a little bit more involved because we have fractions. And my advice for fractions is multiply by the biggest number in the denominator. So fraction, you have a numerator, that's the thing on top. You have a denominator, that's the thing on the bottom. And so what you want to do is multiply every single term by the biggest number in the denominator, in this case the 10. Now this will work. I mean, you can always do this because our guiding principle is you can multiply any number to both sides of the equation. And this is going to work especially if the numbers in the denominators have a common term. So 10 is a common number to 2 and 5 because 2 and 5 both go into 10. So this is going to work pretty nicely. So let's try it out. So we're going to have 2x over 5. I'm going to actually write this out a little bit differently so we can see it better. Okay, now in a different color, I'm going to add what I'm proposing. So I'm proposing to multiply all of these terms by 10 over 1. So notice what I added was in green, and as long as I add that to every single term, so notice the terms in blue are the original equation. However, do notice that I wrote this x as x over 1, and the reason I did that is because fraction multiplication, this is a common error students make, is straight across. So we're going to multiply straight across on top, straight across on bottom. Okay, so we're going to get 2x times 10 would be 20x over 5 times 1, which is 5, minus x times 10 is 10x over 1 times 1, which is 1. X times 10 is 10x over 10 times 1, which is 10, and minus 21 times 10 is 210, divided by 2 times 1, which is 2. Okay, now we can start to perform these divisions. So we can say 20 divided by 5 is 4 with an x on it. 10 divided by 1 is just 10 with an x on it. 10 divided by 10 is 1 with an x on it, so we just write it as 1x or just x. And then 210 divided by 2 is 105. And notice we have eliminated the fractions, and now it's a problem pretty similar to the last one. So I like to go left to right. That's a pretty good way to do it. So 4x take away 10x would be 6x with a minus sign because the bigger number was negative, equals x minus 105. Now we're going to move the x's to the left like we did before. So to do that, we're going to subtract x from both sides. I'm going to write the 1 in here so we can better see this. And when we account for that, minus 6 minus 1, they're both minus, so they're going to combine into a 7 with a minus sign. So it's minus 7x, don't forget the x, equals, these two x's cancel, and 105. Okay, another common mistake I see is students say, okay, I don't want this 7 in front of the x. Remember, our goal was to have just x equal a number, not something in front of the x. And they say, okay, I want to get rid of that minus 7, so I add 7. This 7 is being multiplied into this x, so you can't add to undo multiplication. To undo multiplication, you have to divide. So we're going to divide by minus 7. If I divide the left side by minus 7, I have to divide the right side by minus 7. These minus 7s, any number divided by itself is 1, so we get 1x equals. Now when you have two numbers that are negative and they're being divided, the negatives will go away. It's called a double negative. So 105 divided by 7, and you can use your calculator for this, should be 15. So we have, and again I can drop this 1, x equals 15. Okay, and then it just says to solve, it doesn't say to check, but I am going to still check. So let's check this, make sure it works. Replace any instance of x with 15. Okay, then we're going to get 30 over 5. 15 and 10, I'm going to show you a trick on how to simplify fractions. So 15, you'll agree with me, is 3 times 5. And 10, you'll agree with me, is 2 times 5. But because we now have a times 5 on top, a times 5 on bottom, those will cancel. Anything in a fraction that matches top and bottom can be canceled. So we're left with 3 halves. So we're going to have 30 divided by 5 is 6 equals 3 over 2 minus 21 over 2. 6 take away 15 is 9 with a minus sign because the bigger number is negative. Because these both have a 2 in the denominator, I can combine numerators and make this 3 minus 21 all over 1, 2. 3 minus 21 is 18 with a minus sign because the bigger number is negative, divided by 2. 18 divided by 2 is 9, with the minus sign is going to stick around, so it checks out. Works perfectly. Okay, problem 3 just adds a new wrinkle, not too difficult. It adds the distributive law of mathematics. So we have 0.7 times x plus 0.3. There's an understood multiplication here, so that's times 40 equals 0.5 times a parentheses. Now when I have a number times a parentheses, I have to what we call distribute that number to everything inside the parentheses. So we're going to get 0.7x plus, you can use a calculator for this, 0.3 times 40 is 12 equals 0.5 times x would just be 0.5x, and then 0.5 times 20, again you can use your calculator, is 10. Okay, and now it's a problem no different than the first two. So let's move the numbers over first. Order doesn't quite matter here, but let's get rid of this 12. So we'll get 0.7x. 12's cancel, equal sign drops down, 0.5x drops down, and 10 take away 12 is negative 2. Okay, now we got to move that 5x over, so let's subtract that away. 0.5x. 0.7 take away 0.5 would be 0.2x. Equal sign drops down. 0.5x's cancel, minus 2 drops down. Okay, now, like before, be careful. This 0.2 is being multiplied into the x. So to get rid of that 0.2, let me write this over here. A little more room. So to get rid of that 0.2, we're going to divide by 0.2. But if I divide the left by 0.2, I have to divide the right by 0.2. 0.2 divided by 0.2 is 1. With an x in front, with an x next to it, we tend not to write that 1, so I won't. And then if you take negative 2 divided by 0.2 on your calculator, you will get 10 with a minus sign. So 2 divided by 0.2 is 10, and then that minus sign is going to stick around. So our answer is negative 10. Okay, but like before, let's check that. So we replace all instances of x with negative 10. I already know 0.3 times 40 is 12, so let me just write it as 12 equals 0.5 negative 10 plus 20. So I replace these x's with the negative 10, which we think is correct. Okay, so now negative 10 times 0.7. Tens are nice. When you multiply by tens, you just move the decimal. So if I multiply by 10, I move this decimal 1 to the right, it becomes 7, but with a minus sign because of that minus. Plus 12 equals 0.5 times 20 take away 10 is positive 10. Negative 7 plus 12 is 5. Half of 10 is 5, so it checks perfectly. Okay, in 4, we've got fractions, but the fractions actually have the variables in the denominators, so it's a little bit different. And the first thing it's going to ask for is what are the values or values of the variable that makes the denominator 0. So I'm going to remind you about what division is. So let's look at 20 divided by 5. The answer is 4, but what does that really mean? Division asks how many times does 5 go into 20. So how many 5s do I have to add together to equal 20? So the answer is 4, because if I take 5 plus 5 plus 5 plus 5, I get 20. There are 4 of them. Okay, so just a refresher on what division means. Now, this is interesting if we plug 0 in the denominator. So this is asking how many zeros must I add to get to 20? Well, let's start. 0 plus 0 plus 0 plus 0 plus 0 plus 0, dot, 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 dot. As you can see, we will never get to 20. So I don't care how many zeros you add together, you're not going to reach 20. So this is called undefined. There is no answer here. This is called undefined. In fact, if you type this on your calculator, any number divided by 0, it will say error or undefined, something like that. Now notice that, so let's formalize that generally. Any number divided by 0 is equal to undefined. Now what's interesting is the reverse. What is 0 divided by 20 equal to? So this says how many 20s do I need to add to 0? So how many 20s get me to 0? How many 20s get me to 0? Don't overthink it. The answer is 0. Just don't add any of them. If I take 0 20s, that produces 0. So you can have a number divided into 0. So 0 divided by any number is 0. This one works, this one does not. So a number divided by 0, undefined, but a number divided into 0 is 0. It can work that way. So 0 on top is not a problem. 0 on the bottom is a problem. So when we look at this problem, we're going to look at both any fraction in it. So I have 4 over x. What we don't want is 4 over 0 because of my argument back here. That's undefined. So what value of x would make this 0? Well, the answer is staring right at you. Just match it up if x is 0. The next one's a little trickier to see. What about 14 over 5x? So what we don't want is 14 over 0. So in essence, what we don't want is 5x to equal 0. So you can set that. You can set those equal. What we don't want is 5x equal to 0. So let's set that to 0 and see what number would fill in for x. And then to solve for x, we would divide both sides by 5. So divide by 5, divide by 5. And we would get just 1x over here because the 5s would cancel. And based on this rule down here, 0 divided by any number is 0. We get x equals 0 again. So we get 2 of them, 0 and a blue 0, but we don't need to write these things twice. So if x is 0, it's going to cause a problem in this equation. So we're going to record that in part A. Now in part B it says solve this. So, solve means get x equal to some number. So we've got to use our steps from the first couple problems. So just like before, I'm going to say multiply everything by the biggest number in the denominator. So we're going to have just like before, 4 over x, and then I'm going to save space to put in the multiplication. Then I'm going to have 14 over 5x, and then plus, I'm going to write that as a fraction again, 2 over 1. And now we're going to add in what we're going to multiply. So we're multiplying by 5x over 1. And we're multiplying by 5x over 1. And we're multiplying by 5x over 1. Now there's shortcuts in math. I tend to show them later as we go. So in the beginning I show everything kind of step by step. I line everything up. I make it as simple as possible. And only when we get comfortable with things do I show you shortcuts, because shortcuts can be dangerous, especially if you use them without having a comfort for the basic stuff, the basic math. Okay, so again, how do we multiply fractions? You multiply straight across. So we're going to multiply the tops with the tops straight across, the bottoms with the bottoms straight across. So 4 times 5x is 20 with an x on it. The bottom would be x times 1, which is just x. The top, you'd get 5 times 14, which is 70 with an x on it. And on the bottom, you'd have 5x times 1, which is 5x. And then you get 2 times 5, which is 10x, over 1 times 1, which is 1. Okay, and here's where we can start to cancel things. So with fractions, anything on top and bottom that match can go away. So this x will cancel this x will cancel this x, and let's start with that. Okay, so we have 20 equals 70 divided by 5, which is 14, plus 10x over 1 is just 10x. So I can drop that 1 to get rid of the fractions. Okay, so there's our equation. So we have, let me write it up here so we can do our registry accounting method. So we have 14 plus 10x, and we're going to want to get rid of that 14. So we're going to subtract 14 from both sides. 20 take away 14 is 6. 10x. Now, this 10 is being multiplied into that x, so to get rid of it, we're going to divide both sides by 10. And the 10's cancel here, and we're left with x. But on the left, we have 6 divided by 10. Now, I'm going to use that same trick I showed you a minute ago. Agree with me that 6 is really 2 times 3, and 10 is really 2 times 5. And so what we get is a 2 times, those can cancel because they're the exact same. So we get 3 over 5 equals x. So the answer is 3 over 5. Now you want to check, always, you want to make sure these are not the same. And we'll see a problem where they are and what to do if they are. So basically in part A we said, hey, don't ever let x be 0 because it's going to cause an issue. It's going to give us a divide by 0 error. And so if we do our algebra and it turns out that x should be this number, well, we've got a problem. And I'll show you how to deal with that problem. But for now, just make sure they're different, and they are in this case. So 3/5 is different than 0. So that's our one and only answer, so this problem is good to go. Okay, in problem 5, it's another fraction problem. So just like before, they want us to identify the numbers that won't work. So for 4x over x plus 2, the number that won't work, so 4x, what we don't want is 4x over 0. So let's set x plus 2 equal to 0 and solve. So to solve this, we're going to subtract 2 from both sides and get x. 2's cancel, equal sign drops down, 0 take away 2 is negative 2. X should not be negative 2. Now we look at the 8. The 8 doesn't have a fraction, so there's no number in the bottom that can cause it to be an issue. So let's look at the third term. The third term is negative 8 over x plus 2. But we don't want it to be negative 8 over 0. Now this problem is nice because we already solved that. So this has the same denominator as the other one, so the number that causes it to be 0 would be negative 2 again. So we don't have to write it twice. We've got it recorded once. That should be fine. So negative 2 is the problem child. So we want to avoid that number. Okay, just like before, we are going to multiply everything by one copy of the denominator, the biggest denominator. In this case, it's x plus 2. So we're going to have 4x over x plus 2. I'll give myself room here. Equals 8. Give myself room. Minus 8 over x plus 2. And just like before, I'm going to show you what I'm changing in a different color. So the green right now is exactly what the original problem stated. Actually, I'm going to change this just a bit. 8 over 1. And the blue is what I'm going to add. So I'm going to add x plus 2 over 1 times x plus 2 over 1 times x plus 2 over 1. So notice I'm using that rule again. As long as I do it to every term, I can multiply by whatever I want. Okay, now I'm not going to multiply straight across that is the rule, is to multiply straight across, but I am going to introduce a shortcut here just to make it so this problem isn't a lot nastier than it needs to be. If I have an x plus 2 on the bottom and an x plus 2 on the top, instead of multiplying, I'm going to immediately cancel those. And they become 1s. Okay, so they become 1s when they go away. This x plus 2 and this x plus 2 I'm also going to cancel and make them 1s. And that's going to make my life a lot easier if I do that right now instead of multiplying straight across. Now I don't have a matching x plus 2 in this middle term, so I will have to multiply straight across and get that right. In fact, there is one thing I'm going to add here. I'm going to add a parentheses here because you have to distribute this 8. When I multiply this, I have to take that 8 into both terms. Okay, but let's see what we have left over. Over here we have 4x, 1, 1, and 1. So 4x times 1 is just 4x. And then 1 times 1 is just 1. So the bottom is 1. Over here we have to distribute this 8. So 8 times x is 8x. 8 plus 2, 8 times positive 2 is positive 16. And that's all over 1 times 1 or 1. Then we get, what do we have left here? Minus 8 times 1, which is minus 8. And then red 1 times blue 1, 1 times 1 is just 1. Okay, now this is nice. Technically I have 3 fractions, but because the denominators are all 1, I can just drop them. So dividing any number by 1 does not change it. So 4x divided by 1 is just 4x. So I'm going to write this up here as 4x, and then equals 8x plus 16, and then minus 8. 4x equals 8x. 16 take away 8 is positive 8. And then let's subtract 8x from both sides. Move those x's over to the left-hand side. 4 take away 8 is negative 4. 8x and 8x cancel. And so I get 0, and then this 8 drops down, so I get 8. Okay, and then we get this minus 4 is being multiplied, so we're going to divide by negative 4, divide by negative 4. Negative 4 has become 1, so I have 1x or just x, and 8 divided by 4 is 2 with the minus sign. It's going to stick around, so x should equal minus 2. But I just got done saying these should not match. So our algebra is correct. If you look at those steps, everything we did was legal and correct. So the algebra tells us x has to equal minus 2. But we had already restricted x. We said x should not equal minus 2. So we shouldn't let it be minus 2, but the equation is saying it has to be minus 2. If you get that, if you get these to match, the answer is actually C, which we call the empty set. So you would not actually fill anything in here. On your homework, you're not going to fill anything in. You're going to pick C because it says the answer is empty. This is called the empty set. It's like, imagine you have a list, and in that list contains all the answers to the problem. Well, that list would be empty because there was no answer. So you could also say it has no solution. Okay, so that's how you're going to handle those. If you get those two to match, you're actually going to take C. The solution set is empty. Okay, 6 is no different. It's just it looks a little more complicated. But I'm going to try to show this in a way that will hopefully make it pretty simple. So what we're going to do is we're going to say, okay, we want these denominators to all be the same. So we want everything to look like x plus 3 and x minus 4 on the bottom. And we're going to say, okay, so this first term, it has the x plus 3, but it does not have the x minus 4. So what we're going to do is, I'm going to try to write this. It's got the x plus 3. I'm going to give myself room here because we're going to add some stuff in. Then we're going to look at the second term, the 3. It has the x minus 4, equal sign, 21 is over x minus 3, x minus 4. Okay, so just like before, I'm going to say we're going to add some stuff in. So let's add x minus 4 to this. But just like before, if I add x minus 4 to the bottom, I have to add x minus 4 to the top, and it's being multiplied. Okay, now if you were to cover up the 2 and the x plus 3, and it's hard to show this without erasing it, I hate to erase it, but if you were to cover up the 2 and the x plus 3, look at that in blue, x minus 4 divided by x minus 4. Any number divided by itself, so if I have any number divided by the same thing, it's equal to 1. And then if I take that 1 and I multiply it into 2 over x plus 3, so times 1, I get 2 over x plus 3. So in effect, that blue that I added is just a 1. I'm just multiplying that fraction by 1. But you'll see what that benefits me here in a minute. So any number divided by itself is 1, and then take that 1 multiplied by anything does not change it. Okay, so how would we adjust this 3? Same idea. It's missing the x plus 3, so let's add it, and then let's also add it to the top. And it's being multiplied. So again, if you look at those two x plus 3's in blue, it's really just 1, because it's the same thing divided by itself, and 1 times anything doesn't change it, so I have not altered the equation. Okay, but now that they all have the same denominator, you can cancel the denominator. You can divide it out of every term and it goes away. But before I do that, we have to ask ourselves, what are the problem x's? What x's are going to cause divided by 0? So if I look at x plus 3, and I'm hoping you're going to be able to see this pretty quickly after you do enough of these, the answer, the problem x is negative 3. So if I plug negative 3 in for x right there, I'll get divide by 0. So we don't want the answer to be negative 3. Now we look at x minus 4. The number for x that would make that 0 is positive 4. So if I have 4 minus 4, it would be 0. So I have to restrict those two numbers. Now you can always do this the long way. You can basically say, okay, I don't want x plus 3 to equal 0, so I set it equal to 0, and then subtract 3 from both sides, and you get x equals minus 3. And you can say, okay, I don't want x minus 4 to equal 0, so let's set it equal to 0, and then I add 4 to both sides and get x equals 4. So you can do it the long way, or I'm hoping you can just look at it and say, oh, the opposite number is the one I don't want. These are the same thing. So the opposite number of 3 is minus 3, that's the one I don't want. The opposite number of 4 is minus 4 is positive 4, that's the one I don't want. So those are also accounted for. Okay, so we got those restricted values. Now back to this problem. Now that the denominators all match, I can divide them all out, make them all 1, and all you're left with is the top part. So let's write that. We're going to have 2 x minus 4 plus x plus 3 times 3 equals 21. And now this is where we need the distributive rule again, so that 2 is going to distribute into both. This 3 is going to distribute into both. So we get 2 times x is 2x, minus 2 times 4 is 8, plus 3 times x is 3x, plus 3 times 3 is 9 equals 21. This 2x plus that 3x would become 5x's. 9 take away 8 is 1. And here's where we can subtract 1 from both sides. Get 5x equals 20. And then divide both sides by 5. 5 and 5 cancel. I'm left with 1x. 20 divided by 5 is 4. So x equals 4. But catch yourself. These match, and they should not match. If they match, you select C. So our algebra said we wanted. So you're not going to actually type in 4 there on your homework. You're going to have to type a number. You actually don't want to type it because we just said it should never be 4, but the only answer is 4. So if that's the case, then the answer is empty set. So pick C, and that is that problem. Okay, problem 8 is pretty similar to what we've seen. Let me write it over here a little bigger. 7x plus 8 equals 4x plus 8. And let's get rid of this 8 on the left. I tend to like my x's on the left. So we get 7x, equal sign drops down, 4x drops down. These 8's canceled, so I didn't write them. But interesting, these 8's also cancel. So I don't have any numbers left. Okay, so now like I said, I like to have my x's on the left. So let's subtract 4x from both sides. 7 take away 4 is 3 with an x on it. Equal sign drops down. Now, this is where students will make an error sometimes. If I have 4x and I take away 4x, what is left? Nothing. But how do we represent nothing? 0. You need to write that 0 over there. Otherwise, you might confuse yourself. Okay, 3x equals 0. We're not quite done. Let's solve for x. 3 is being multiplied into x, so to get rid of it, we divide by 3. But if I divide the left by 3, I have to divide the right by 3. These 3's cancel. I'm left with 1x. Equal sign drops down. Now this is where we have to remember. How many 3's does it take to go into 0? 0 3's. So that is an answer. You can have 0 on top. That's okay. It was when 0 was on the bottom that we had a problem. So in this problem, if x equals 0, that is the solution to the problem. Now let's look at that. If x is 0, this 7x goes away, this 4x goes away, because 0 times 4 is 0, 0 times 7 is 0, and you're left with 8 equals 8. When you have a solution like this, this is true. So we just checked our 0, and it's correct. When you have x equaling a number, that's called an identity. So we have, I'm sorry, not an identity. That's called a conditional equation. So this equation only works under one condition, and that is if x equals 0. So we're going to have 3 things here. A conditional equation is you're going to solve it, and x equals a number. An identity is when your x's will actually go away. So as you're solving it, your x's will go away, and you'll end up with just a number equals a number. So now don't confuse it with this. This x went away only because we put the condition that x was equal to 0. I'm talking about if in the algebra steps your x's disappear and you just get number equals number, that's called an identity. An inconsistent equation is when, like we saw before, we get x equals 4, but we said, hey, x can't equal 4. So that's an inconsistency. You might also see something like, as you do your algebra, you might get down to something like 5 equals 3 or 0 equals 2. Okay, so if you get something like that, that's also inconsistent. So we got 2 numbers that are different and we're saying they're equal. That can't be true. Okay, so we'll see some more on this to help you understand these 3 conditions that you have to pick at the end. But that's it for problem 7. Okay, so for problem 8, pretty similar to the last one. Or I shouldn't say the last one, problem 6. Okay, we're divided by x minus 4. So let's immediately write over here on the side that x should not equal positive 4. Right? So if x is positive 4, we're going to get divided by 0. So that's a problem. Okay, and once we've written that, let's just keep that in mind. Okay, so now we're going to do what I did before. We're going to multiply everything times x minus 4. Okay, so right now it's the same equation we had before. So it's the same equation, just spread out a little bit, and 5 I wrote as a fraction. Now we're going to multiply by that x minus 4 over 1. Multiply by x minus 4 over 1. So I'm multiplying every term by the denominator. And notice every green term got a blue multiply. Okay, so now, like before, I'm not going to distribute yet. I'm not going to multiply across because I'm going to notice x minus 4 matches x minus 4, they cancel. They become 1s. X minus 4 matches x minus 4, they cancel, they become 1s. And that's an important step so that I can make my life a little simpler. And I'm going to add parentheses here just so I know that I have to distribute this 5. My pen gets so thick here. Okay, so now let's see what we have left. We have a 4 times 1, a 1 times a 1. So this whole thing is just going to be 4 over 1. And let's look at the and then the equal sign. Okay, what's left out of this mess? We've got a 16 times a red 1, so it's 16 on top, divided by red 1 times blue 1, just 1 times 1. Now we have this green 5 has to distribute, so we have 5 times x, which is 5x, 5 times minus 4, which is minus 20, all over 1 times 1, which is 1. Okay, now again, like I said, if the bottoms all match, if they have the same number, the same thing, you can just drop them all, so you can cancel all these 1s, and it just becomes 4 equals 16, so the fraction aspect is gone, plus 5x minus 20. Ooh, boy, I left an x off here, so this 4 should have an x on it. Real careful there. Okay, so I forgot this x, so this x would be here. 4x times 1 is 4x. 1 times 1 is 1. I think that's all I need to do is add that back in. Okay, so now we can have 4x equals 16 take away 20 is minus 4 plus 5x. Okay, I like to have the x's on the left, so let's subtract 5x away from both sides. 4 take away 5 is minus 1x. Equal sign drops down, minus 4 drops down. 5x and minus 5x cancel. Now, minus x and minus 4, because both sides have a minus, I can either divide by minus or multiply by minus, or you can just flip everything. I like to flip. So instead of a minus x, it's a positive x. Equal sign doesn't change. Instead of a minus 4, it's plus 4. So x equals 4. But again, we had just stated x should not equal 4. And our algebra is saying it should be 4. If we get that contradiction, the solution set is empty and it's an inconsistent equation. Okay, so the solution set is empty, it's an inconsistent. In fact, I can tell you that these two will always be matched together. If the solution set is any real number, that's an identity. So these two are always matched together. And if you get a conditional equation, the next most common one, you say x has to equal a certain number, then these two are tied together. That's a conditional equation. Okay, and that's it for 8. Okay, in problem 9, it's another fraction one, and we're going to show you yet another trick, and that is, right now our 3 numbers in the denominator are 1, 2, and 3. So we have to think of a number, least common multiple, a number that all 3 of those numbers go into. And you can usually get it by just combining, by multiplying. So if I multiply 3, 2, and 1, I will get 6. So 6 is a number that all 3 of those numbers go into evenly. So we're going to multiply everything by 6. So we're going to say 6 times x plus 3 over 2. And then we're going to have minus 9 times 6 equals 6 times 2x minus 4 over 3. Okay, now before I actually do these multiplications, I'm going to first simplify. I'm going to say, well, 6 divided by 2 is just 3. So instead of multiplying everything by 6, I'm going to multiply this term by 3. So it actually becomes 3 times that term on top with parentheses so that I know to distribute. 9 times 6 is 54 equals, and I'm going to do the same thing. I'm going to say, okay, 6 divided by 3 is 2. So instead of multiplying everything by 6, I'm going to multiply by 2. And again, I need to write the top part in parentheses so I know to distribute. Okay, so in fact, that would be the next step. Distribute these numbers now. So we're going to get 3x plus 9 minus 54 equals 4x minus 8. And 9 take away 54 is 45. And let's add 45 to both sides. So we get 3x equals 4x plus 37. Since this minus 8 is going to actually pull that 45 lower. And then let's subtract 4x from both sides. More than one way to do it. You don't have to do it in this order, but this will get us there. 3 take away 4 is minus x equals 37. Therefore, positive x has to equal minus 37. Just flip it. Minus becomes plus, plus becomes minus. So x is equal to negative 37. And that's a conditional because basically we're saying x has to be 37, negative 37 for this thing to balance. Now notice that I didn't have to check to see if there were any x's that wouldn't work. If there is no x in the denominator, all values of x should work because you're not going to get a divide by 0 situation. And that's problem 9. Okay, I have problem 10 on the notes, but it's actually a problem. It's just a little more complicated than I want us to worry about. So you won't see a homework problem like this, and we're just going to skip it. So you don't have to worry about filling this in your notes. So that will actually complete section 1.2.